Hello everyone, Philip here again, back with Queen Anne's Reef. Today we're going to be talking about calcium reactors, how to set them up, install them. One of the biggest questions I've gotten and a lot of people are very fearful of are calcium reactors. So today we're just basically going to crush that fear and go over the basic know-how of calcium reactors. We're going to go through all the things for a basic reactor setup that you're going to need, and how to set it up, and what we're going to be doing. We don't have any lights on in the reef room yet. It's so early in the morning right now. We did a restart on this old frag system, and I just wanted to. I basically just cleaned everything, the coral out and everything, and wiped it out, started it over. So this is going to be the system that we're going to set up this new calcium reactor setup on. Okay, so let's start off with our parts on this. So to begin with, you're going to need a Milwaukee pH controller, something very basic, simple unit. We'll go over everything in this setup. We'll go over through every piece and how to set up as we're going along. pH controller, it's going to basically be monitoring the pH that's inside the calcium reactor. The next piece is going to be the Camor FX STP2 Wi-Fi controlled peristaltic pump. It's a continuous dosing pump. This is, I highly recommend this. It's been a fantastic one. We run it on our other systems and we love this unit. The next one is going to be the carbon doser. The carbon doser is going to be your CO2 regulator that goes on your actual CO2 tank. The best way to describe this is basically it controls your bubble count that's going to be going into the reactor from the CO2 tank. It's very precise, very accurate, and it'll work a whole lot better than a standard regulator and solenoid control. It's way more precise, and we'll get into that. The Trident here is just another add-on. We already have one already here in the reef room that runs the 310. It's going to be a second add-on that'll be for the precision of measuring the alkalinity, calcium, and magnesium in this frag system. So that's not a necessity. It's in with this purchase, and it's going to go along with it. The calcium reactor itself is nothing but an acrylic media holder that it has a recirculating pump on the back, a bubble counter. This one actually has a input filter with a water filter that just filters out your water before it goes into the reactor. And it just basically recirculates water while your calcium media is inside in this tube. And then obviously we use two little fishies reborn. Some people like the little reborn, or I think this is just the standard reborn, yes. And the difference is the chunk size is like, I think the little reborn is like little smaller granules, whereas the regular reborn is just bigger, chunkier media. It tends to not break down as fast. And then obviously we have our 5-pound CO2 tank. Also, if you want to pick up some the clamp-on dosing holders and some dosing tubing, that's also a good idea. And I think that's going to be your basic setup to get going for your calcium reactor. Okay, so we're going to be working with the Aquamax calcium reactor on this one. The basic function, and you can use any reactor as long as basically it's going to be recirculating the media. It has to have a pH port for your pH probe and a type of way to inject CO2 into the system. Other than that, it just needs to have water going in and out and then a recirculating pump. So the purpose of the actual reactor is to break down the actual calcium media that you have put into the reactor. Now, when they use the term calcium reactor, you're actually not shooting for actual calcium. The calcium is the byproduct of a calcium reactor. So no matter what your settings are on your reactor, whether you set your pH lower or higher, you're always going to get calcium. The point of this is actually alkalinity. So, and we'll talk about that a little bit more in a little bit, but the the point of it is to get a steady, constant effluent rate for your alkalinity. And then once you get that level set, then outside of coral growth and maybe adding more coral to the system, it keeps a constant, steady effluent rate of alkalinity going into the system where you don't have to constantly adjust for dosing and things like that. But as you learn the system, you will get better at knowing where your happy fine line is. But the calcium itself is just strictly a byproduct. You always have, you can almost get to the point where you really don't even have to test for calcium if you're running a calcium reactor, because if you're running a calcium reactor, you will always have calcium at almost the perfect point in your system. You might have a weird case where it's not that way, but from my experience, and I've been running reactors 20 years, calcium is usually dead on if you're running a calcium reactor. So the point of this, alkalinity. So you will be filling this up roughly about to here with calcium media. We'll get to that and I'll show you how to put all that in here in just a second. Water will come in through the inlet off of the sump or some clean source where you're drawing water from the system. You will have an inlet. This one actually has a filter. It runs through the filter, comes in here, and they do have a type of regulator here. I just leave it wide open on this setup. I don't never use it. I honestly don't know why they set it up that way, especially if you're using a Kamoer and then another type of dosing pump or something on the other side. And then you will have it go through, as it comes in, the water will come in into the reactor through the recirculator, and then it just goes down there and it just continuously refills, and then eventually the water will come out your output side back into the sump, or if you're dosing directly in the tank or however. I always recommend pulling from the sump upstream and then dosing your output side on the downstream, somewhere near the pump. People are going to have debates about how to do it, where to put it, things like that. It's just how I've done it. I always draw from upstream, put it back downstream. Now, as far as the CO2 ports, you're going to have an inlet that's going to be coming off of your carbon doser from the CO2 tank, and we'll get to the CO2 tank carbon doser in a little bit. But your air will plug in on your inlet port for your air on the bottom side of your bubble counter. The bubble counter is visually what's showing how many bubble counts that's going to be going into the reactor. So you can actually, as the carbon doser releases a bubble for how many counts that you set it digitally on the carbon doser, you can visually see it here on the counter inside this tube here. In this side of this tube, this is not water, this is glycerin. I recommend, some people use like RODI water in their bubble counter tube. I definitely wouldn't put salt water in there. That way, if it does back up into your tube, you will have a check valve. There are different types of stainless check valves. You put whatever type of check valve on your inlet side, but you just don't want the water or whatever you're using in your bubble count to back up into your carbon doser, because it will ruin it. So after the bubble count, you're going to be putting it into the center drop tube that goes down to your bubble plate into the bottom of the reactor. Now, as the CO2 comes in and it goes to the bottom, this bubble plate, which we'll pull out in a little bit and show it to you, the bubble plate will disperse the CO2 up through the media, and this is what causes the breakdown. As it recirculates over and over and over again, it will drop the pH in the reactor. Next components, this is your basic 5-pound CO2 tank. You can get it from most of your online stores. You can shop around for them and get the best price, but nothing strange or fancy, just a basic 5-pound CO2 tank. This component is your carbon doser. This is basically your electronic, it's a digital electronic regulator that is going to give you your precise regulation for your CO2 that's going to be going into your reactor. So this is what the unit looks like. It's going to have your two different dials on it. One is your high pressure side, and then your low pressure side, which is the inside. The high pressure side is what's going to be coming off the tank, how much poundage is actually in the tank, PSI. I think it's only PSI. Yeah, it does not have bar on it. So it's only PSI readings on this and this. Let's see, it's made in the USA. So anyone outside the USA that watches my channel, I'm sorry, we're just doing everything in PSI here, not bar. So you'll be reading this on the high pressure side coming off the tank, and then on the low pressure side, which you will regulate right here, that's going into the calcium reactor, will be no more than, I would say no more than 10 pounds at the most. Most people are going to say that you're going to want to set it between 6 to 9 pounds to be able to keep good pressure going through the lines into the bubble counter. I never set it anything higher than 9 pounds roughly. If you ever see anything start creeping up higher than, I would say, 15 pounds, be careful, because you're basically pressurizing your calcium reactor. You don't want to do that. Basically, we're just wanting to drop small increments of air into the reactor. You're not wanting to pressurize your reactor. Otherwise, you're basically making a bomb. So let's try to keep our pressure as low as possible. That's why we have the low pressure gauge to read that. And this thing is very precise. It stays pretty much right on the money. I've never had a problem with this, no sticks or anything like that. The only time it gets weird is when it starts to run out of air, and then it's the low pressure obviously is going to be harder to read, because as the pressure gets lower on the high pressure side, then you're just basically running out of gas. But other than that, this has been a fantastic unit. You won't ever have any issues with the carbon doser. This will mount onto the CO2 tank just like this. It has copper threading, mates up to it, and I'm going to have to go get a pipe wrench, or an adjustable wrench, just to cinch this up. When we're cinching this up, do not over tighten it. Get it just snug enough that you're seating the seal against this fitting to this fitting. And just as you get done, you can check it for leaks, listen to it. You can put a little bit of light soapy water around the edges of the threads to just try to inspect to make sure this unit's not leaking. But most of the time, I've never had an issue with either of these leaking. They made up really well, unless you get like a very old CO2 container that's been recycled through the facility and I think it's called hydration. Is it hydration? The hydration test, whatever it is. You can see the stamps on the tank. The newer tanks, you won't ever have to worry about anything. Sometimes the old ones, but they usually inspect them and make sure the tank's in good order. They go through quality control. So that's all there is basically to put the tank on the unit. Then you will actually have let's just look on the bottom. The unit that the outlet side where the air comes out has a port where the line will go out of this into the reactor, and you also have your power port right here at the bottom. The power port will plug into the pH controller, which I'll show you in a little bit. But basically, and this one has a small little, I think it's a little blue LED if I remember what's on these units. I can't remember. Maybe it doesn't. I think it's a blue LED. But anyway, this will plug into your pH controller to tell this when to power up this unit later on when it's calling for CO2. We'll get to that in a second. Okay, so now let's talk about the pH controller. Get all these cables untangled. I just have them sitting here. Apologize. So the Milwaukee pH controllers, you can go online, find these very easy. They're very readily accessible, and they're fairly inexpensive. Very basic way to set up your calcium reactor for pH control. There are other companies that we'll talk about that you can actually buy monitoring systems. You guys, if you watch my channel, you know what brand I use, that you can program through the program. You can control your pH in your reactor. That way you don't have to use one of these. But for in this case, for a basic setup for your normal beginner users, this is the best go-to for pH control in the reactor. And you basically will be setting the pH inside the reactor by this dial. You always want to set the switch to be to come on for the above setting. That way, once the pH reads above a certain level, you want it to cut on. Once it cuts on, it'll start injecting the CO2 into the reactor, and then once it's hit its set point, then this will cut off. In turn, it'll also turn off the carbon doser. So how that is done is this comes with a secondary auxiliary plug that will plug into your main power supply. This will plug into wherever you're going to get your main power from for the carbon doser, but this goes before the carbon doser. You can see the plug on the back, and then it also has its own standalone power supply that will be plugging into the unit. This powers this unit. This one tells when to turn the carbon doser on and off. So, like I said, we'll just pretend the carbon doser is plugged in here. Carbon doser will plug into here. Okay? We're going to ignore this because that's just the main power. There will also be a pH probe that's going into the calcium reactor. So while this is monitoring your pH in your calcium reactor, when it gets to that certain set point, and we're going to always tell you, you're going to have to figure out where your set point is on your reactor for your melting point. I would recommend anywhere between 6.5 to 6.9 is going to be your sweet spot, but you're just going to have to find it, because if you go too low, then you're going to make a mush out of your calcium unit and you're just going to throw it out and you're going to have to start it all over again. But if you get that nice sweet spot, then your effluent rate that's going to be coming out of your reactor is going to be spot on. You'll maximize your reactor media, and you'll keep it dialed in really nice. So back to it. Like I said, the pH probe will be plugging in here. I don't have it over here right now. It's sitting over there. It'll be in the reactor monitoring. So while the pH controller is watching the pH in the reactor, as it reads, say it sees, we're waiting on 6.6. If it starts seeing 6.7, 6.8, it's going to cut on. In turn, it's going to cut this on. In turn, it's going to cut on the carbon doser. Carbon doser turns on, the bubble counter starts counting bubbles that's going into the reactor. As it releases the bubbles into the reactor, it's going to start dropping the pH level inside of the reactor. Once it satisfies the pH controller and the pH controller sees the proper pH in the reactor, then this shuts off, turns this off, turns this off. And then that's all there is to it as far as the controls. It's very basic and very simple. And that is how deep it goes as far as monitoring the pH in the reactor. The reason the reactor is safe, you won't ever, like using calcwaser when you're dosing calcwaser, the doser gets away from you and you're continuously dosing or something like that, then it's just gonna, your numbers will get way out of whack with calcwaser or anything like a dosing pump, or just using 2-part or whatever you're using at the moment. If for some reason the CO2 goes crazy and it starts just dosing, you might see some pH drop in the main display, but that's about all you're going to see, as long as it catches or something like that. What will happen though, and I've seen it happen myself, is if you just start to see the CO2 drop in the reactor and that media goes to mush, it's going to make a mess. But luckily, you're not going to lose. I wouldn't say you're not going to. You have a less chance of losing a lot of stuff in the display, because that accident's contained to the reactor. Say you melt it and you've got to start it over or something like that. It's a whole lot easier to clean up versus having to clean up and doing water changes and stuff like that in the main display. So it's a little bit safer. We might have some debates with other people that are scared of reactors or they don't like reactors or stuff like that, but I've never had a big fiasco happen. The worst case I had my set point that was too low on my media, and it just melted my media, and I had a mess and I had to clean it up. That was about it. I never had no coral loss or anything like that. So hopefully that's not too complicated, but that's your basic controlling part of the reactor. Okay, now we're going to talk about the Calmower pump. The Calmower is an excellent dosing pump. I highly recommend it when you're running a calcium reactor. You actually can use it in other applications too, but the main application that you'll see in the reefing community is for calcium reactors. A lot of people love these things. You can Wi-Fi control them. I travel a lot, so I'm able to actually make adjustments if I need to on the fly with this. On my programming, I've actually been able to kind of get around that. I'll get a good set point, a sweet spot on this, and then I'll use my programming to control when my carbon doser cuts on and off, the things I was talking about earlier. But if you don't have a way to program your carbon doser, or all that other extra way to monitor, if you're just chemically testing with Salifert or Hanna checkers or anything like that, and you gotta control it that way, this is still a good way to be able to control your pump if you're not home. The Trident helps monitor that, and you also can control this via programming. If you're getting what if you're understanding what I'm getting at. So there's a lot of perks to using this and the Trident and other additions, but like I said, for this video purpose, we're going to try to keep everything as simple as possible for the basic setups. This pump is going to be very precise. You can dose, I think it's down to the 0.1, I think it's 0.1 milliliter, or maybe even smaller than that. I can't even remember, like last time I had to calibrate mine, I was playing with it into, I don't have one of my small beakers over here, but you can get very precise of how much you want to dose, or if you want to run it a whole lot faster. I think it'll do 100, if I'm not mistaken. It might be higher than this, but I think it'll do 120 milliliters per minute if you wanted to dose that much that quick. I've never run mine wide open like that. Typically, in most systems that I've even set up at my customers' houses, usually they're running between 12 milliliters per minute to upwards, I've seen 30 milliliters per minute. I've not really seen much of anything over 30, 35 milliliters per minute. Even on my 310, I want to say I maybe run it roughly at 20, 21 milliliters per minute. And that's plenty enough to keep up with the big 310. And like I said, also it's going to be according to where you're setting your set point for your melting point to get your more potent effluent rate out of the reactor. So back to Calmower. This is what the pump's going to look like. Very simple pump. All the controls are right here on screen. If you don't have a way to Wi-Fi control it, you still can do it manually by dialing the wheel here. Basically, just water comes in and water comes out, and that's all there is to it. There's a QR code for scanning it in when you want to register it and getting online with it, so you can control it via Wi-Fi. I always do all that on those. It makes it life so much simpler when you can get online with it and monitor it, and you can actually see the tube life, how many cycles it's been through, the speed, everything like that. So every once in a while you will have to change the pump wheel in it. The bearings can go out, the rollers, and also this tube, the surgical tube that's in there, the wheels massages, the water rolls through. That will have to be swapped every once in a while. And like I said, the readout on the app from your phone will give you the life of the tube, and you can see how much cycle count is actually on it. Very good unit. Okay, so back to the reactor. What next we're going to do is fill the reactor full of calcium media. So just wanted to show you guys real quick. This is the bubble plate that I was telling you about. It looks very similar to like the ones that are in the bottom of skimmers. The lights in the reef room are starting to come on for the day. So basically it's just dispersing the CO2 through the media. Nothing, anything wild fancy. But we will be filling up this with the media. So make sure when you drop this in, there should be a little inside lip that this sits down on. And most of the makers of this bubble plate, they will have a bottom, like where it can't go but so far, because you don't want this tube past the bubble plate, because you're going to be blocking airflow. Also, that's why they have the spacer gap on the bottom of the reactor. That way the CO2 comes out and disperses properly. So make sure everything drops in nice and even, nothing is jammed in there. I recommend either getting a shot glass or a dosing cup or something like that. Drop it on the end of this, the tube. That way, as you're putting this media in, that you don't drop any media down into that tube, because that's just asking for problems. Make sure you get all the media down around the actual reactor, excuse me. I've actually already poured some out into a bucket, so this is how we're going to do it. You can use a funnel. I use a little measuring cup with a pour end on it. And I'm making a mess. And it's going to happen when you do this too. It'll want to spill over a little bit. Basically, all of what this reactor media is cleaned and washed crushed coral. You know, old dead skeleton coral that two little fishies have prepared for us already. They cleaned it up, washed it up, made it sterile for you. That way it's ready to go in your reactor and you're not bringing any unwanted pests or diseases or whatever. They have it ready to go for you. So we're getting pretty close to where we want to be with this. Like I said, you don't want to fill it all the way up, because you have to have a little bit of space gap for your pH probe to go down into the reactor. That's about right. That's about where you want to start with, just a few inches shy of the top. Everything's seated down in there properly. Flat. All right, next thing, let's get our lid back on. And this is a little bit of aggravating task. You got all this that's got to go back on. Then the last piece will be, actually, let me fill this with tank water first before we do this. That way that saves us a step of later having to wait on the pump to fill this up. So I'm just going to use that same cup that I was using. This is not dirty or anything, just the calcium reactor stuff. And I'm just going to pull water out of the sump and start to fill this unit with water. It just gives it a head start. All over me though. Pretty close enough. We'll let the pump do the rest of it. Plus this media is going to absorb some of that water too. All right, now we can get our lid on. On your recirculator pump, I recommend marking what your inlet, because you may have to, this one actually has a cover, a sound cover. It's not the greatest sound cover, but it has a sound cover on it. So make sure you know what you're recirculating, what direction your recirculating pump is going. I like pulling from the actual media up into, and then flowing this way into the pump, and then coming back and dropping into the tube that goes to the bottom. That's usually the way most people like to recirculate their water in their pump. That way, as the water comes through the pump, it pushes the CO2 back down to the bottom of the reactor. And realistically, I guess if you recirculated it the other way, it would work. But to be more efficient, to push the CO2 back down to the bottom of the reactor where the bubble plate is, that's the proper way to do it. So just make sure you got your inlet and outlet sides here on your recirculating pump in the proper locations. Like I said, this one has the additional little filter and bubble counter here on the side, so it has to have a higher screw as you're tightening this down. And also, as you're tightening this down, make sure you're not pinching your O-ring. I've actually already pre-lubricated that O-ring, so it's good to go. Let me get this thing a little bit better aligned. There we go. But tighten your top plate evenly. You know, same way you would tighten the lug nuts on a vehicle. Just go across in like a star pattern as you're tightening it. Don't do it unevenly. That way you're going to get a funky sandwich, and you may actually pinch your O-ring improperly. Excuse me. Don't go crazy over tightening your acrylic screws. Strip the threads out, but make sure you're getting them good and finger tight. Check all your lines. Make sure everything's plugged in properly. This specific reactor actually has the clips that go with them after you plug everything in. They're safety clips. That way it saves from possibly pulling back out. And I think we're ready to set the reactor in. We've already prepped the tank. I had my adjustable wrench. I tightened this down, checked it for leaks. So that's ready to go in. Actually, I think that needs to go in first. I've already got our electrical stuff in. I've mounted our Milwaukee pH controller. Is already mounted into the frame of the display. So it's in here. I still have to put the pH probe into this reactor. I'll show you that in just a little bit. So yeah, I'm going to go ahead and set this in. Actually, I got to move that electrical. I just said that. There we go. I'm going to set this slightly out of the way for now. In our pH controller. It's not going to give us anything just yet, but we're just getting everything situated. And I know you guys can't see it right now, but we're going to come back and I'm going to show you everything once I get it set in and organized. Just a second. Okay, so have our pH probe here. It's going to go into this watertight grommet here. This is where we'll be taking our readings from on the reactor. That way we know we have proper level of pH inside of the reactor. Now this watertight grommet, it seals up pretty good, so you don't have to sit here and put a wrench on it or just extremely over tighten it. It does pretty well with finger tightening it. If you want to use a wrench on it, go ahead and try it if you want. My grip's pretty decently good, so I don't need to really use a wrench, and it seals up really well. And that's all to setting up your reactor, and it's ready to go into the aquarium, or excuse me, not the aquarium, the display. So now that we've got everything all in place, everything is plumbed properly, tubing's in, the pH controller's in, the 5 pound tank, excuse me, regulator, carbon doser, reactor's in, we've got the Camor set in place, and the dosing lines, they're both in place. So now what we're gonna do, let's see, let's start with tracing the route of how the water flowed. So we're coming here, you can see where the sock off the overflow chamber is, coming down to the first chamber. There will be a skimmer here. I just temporarily pulled the skimmer out right now. Put our first bracket here to pull water. So this is our draw line. Let me back up for just a second. So there is a debate on pushing water versus pulling water through a reactor. This specific reactor, I've noticed, doesn't do well with pushing water. It tends to want to pick up a lot of air bubbles, and then I'll end up having a lot of, it causes a lot of circulating pump noise, and the bubbles will just sit there and make more and more and churn over and over again. So I've actually had better luck with this specific reactor. I've had other reactors I've had to be able to push through, but this one likes to pull water through. So we're going to start here. Okay, so we're coming out of the first chamber, going through this line. You can see where it comes up. I'm just feeding it around behind. Comes into the filter. We're going up through the filter, obviously going through the reactor like we talked about earlier. It's recirculating, and then we're coming back out over here. Now, the reason this orange line is here is because this actual dosing line does not fit this fitting. So we're doing like a little rigging crossover. It works fine. It actually fits very tight and everything. I've got another one that had to do the same thing. Whatever you got to make work. There's not a lot of pressure on these lines. It's literally just whatever the pressure off the Camor is pushing. It's not much at all. So coming out of the reactor, we're coming back over, and you can see as the line comes back behind the sump, and we're coming into the Camor right here. The Camor, the pump will be circulating. I'm just going to turn it on. It's running dry right now, but that's what it's basically going to do. You're going to circulate here. I'm going to turn it back off because there's no water, and it's not going to hurt it, but I just don't feel like running it dry. Then it'll come back down, and then we're going behind the leg right there back into the dosing clamp down through here, and we're dropping right here where the return goes back up to the frag display. That's your basics for your water flow. Okay, next we're going to talk about how the CO2 injects from the carbon doser into the bubble count. So I'm going to have to lean in to let you guys see this. You can actually see where I've already plumbed in the air line off the carbon doser. This dial here is where we set our bubble count, and the further you turn it to the clockwise direction, you're gonna get a slower bubble count. So this one is second bubbles per second, or actually seconds per bubble. So you can go as slow as you want down to point 0.1. Let me see if I can get that to focus right. It is not wanting to focus, is it? There we go. 0.1 to all the way up to 10 plus. And we'll control that and set that later. Usually the rate is going to be like 3 or 4, I want to say it's around 3 seconds per one bubble. It'll be more like, if you had a cadence to it, it would be like flat. You'll see an actual LED indicator down here on the bubble counter. It'll be like flash, flash, flash. So it's not very fast how much you inject CO2. You shouldn't require a massive amount of CO2 to go into your reactor to get your pH to drop. So back to it. Plumbing comes around. You can see where the hose comes up to your bubble count, and then it just goes into your reactor. All right, now we're going to talk about the pH controller. So as you can see right now, the tank water is actually, because we just filled with tank water, it's reading around 8.1 with the pH controller. So that's what we're seeing and reading inside the reactor is just natural tank water. It's not had any CO2 injected into it. We've got our set point right now. It's got a glare. It's roughly at, I'd say 6.7, maybe 6.8. I may be adjusting that back down. It might be actually as high as 7.0. But that does need to be around 6.6, 6.7. I wouldn't go any lower than 6.4, honestly. You can see the indicator light flashing right now, which is saying that the recommended value is higher than what it's calling for. So it is actually would be normally turning it on. We have power on the unit, but we actually don't have power on the carbon doser. It's not plugged in the back, so I don't want to power that unit to call for that. We'll get to that in a second. But normally it would be calling to tell the carbon doser to turn on right now. All right. So now that we have everything plumbed in, everything is plugged in, and we are running our Calibration pump now. We're running, and we do have an effluent coming out of the output side of the drip tube, the dosing line, excuse me. And everything is running like it's supposed to. Like we said before, we have the pH level set properly for the set point. So as you can already see, I've got it, the carbon doser in operation now. We've got the bubble rate set to where we want it. You can see the flash rate, and I think it's set right now roughly almost about 3 seconds per bubble. And you can see on the bubble count over here, like I think I mentioned this before, this is not water, this is actually glycerin. You can get it in a place, your local drugstore or something like that, and you just fill that full of glycerin. It helps with like a better idea of a proper bubble count. Like I said, you could use RODI in it. So you can watch your, digitally you can watch your LED flash for your bubble count, and you're also going to get to see your bubble count. Recirculator is going to push it through the reactor, and obviously we're going to still continue to circulate water through the system via the Calibration pump. Now over here you have your regulator set point that'll be dialed in, and you can watch your gauge here. You can see where we've got it roughly about 6 to 7 psi. That's where I would recommend setting it. Like I said before, try not to set the pressure too high on it, because you're essentially making a pressurized bomb reactor type deal. You can see the high pressure side, how much poundage we have left in the actual tank. So this is the final setup of how it's going to be. Somewhat similar to this. You can do it in different ways if you're using other controllable devices through like a Trident and an Apex system or something like that. You can program it, but this is as basic as you could possibly get outside of doing something a little bit cheaper with a different type of dosing pump or whatnot and a different regulator. But I highly recommend, if you're going to do a calcium reactor, try to do it try not to cheap out with it, because you'll get better performance if you go a somewhat similar route to like this. If you guys got any questions, as you always know, please leave comments, or just you can hit us up on YouTube and Facebook and ask questions. Anything and everything, we'll try to get back to you as quick as we can. But I hope this has been a very helpful video and you guys use it, and don't be scared of calcium reactors. I know a lot of people out there are scared of reactors, and there's no reason to be scared of them. They're actually a really good tool to use in the reefing hobby to stabilize alkalinity and calcium. And like I said, I hope you guys enjoyed this.
just please like and share. And if you guys haven't subscribed to our channel yet, we always appreciate the new subscribers. And hopefully we'll get to see you guys next time here on Queen Anne's Reef. You guys have a good one.